Welcome to Lyons Township High School. Today we have an example of curve straightening. And I would start with the following. In a moment I would pause the video and we're going to copy some data down. And the data that I'm giving you here is for pizzas. And specifically, this is the diameter of 5 different pizzas. And this is the mass of each of those 5 pizzas. So what I've done here is to get a data table, diameters in inches, masses in grams, and I went ahead and graphed this. So I'm doing mass versus diameter. So I would suggest if you'd like, you can copy this graph. You don't need to, but I will use this to demonstrate something. So it's mass versus diameter. So I'll give you a moment. If you can pause the video, if you want to copy that data down and or the graph, that'd be great. Thank you. All right. So what we're going to do is we're going to do a curve straightening, and we're going to find something out about the pizza. Okay. So if you graph mass versus diameter, and you graph these 5 points on a graph paper or in your calculator or whatever, you'll notice that it's not linear. Okay. If you were to graph this, it is quadratic. Okay. So what are we going to graph to do the following 2 things? We're gonna figure out a graph to straighten that out. So what do we graph on the x-axis to straighten that graph out? And number 2 is we're going to find the density of the pizza. Okay. Now before we do that, let's talk about formula. So this part of this you are not going to have to do in our class. Okay. But I am going to just briefly derive the formula that relates the mass to the diameter of the pizza. So it's pretty simple. Mass is density times volume. Now in physics, for density we use a little rho and then volume. Okay, so the mass is equal to rho. Well, what's the volume of a pizza? Well, it's a cylinder. So it is the height of the pizza times the area of the pizza. It's a cylinder. That's the equation for volume. And we're going to go further. Area. So we got rho, we got height. Area is pi r squared for a circle. Okay. And we didn't give you radius, we gave you diameter. This is what you get in an actual, pizza. So radius is diameter over 2. And we're going to square that, so it's going to be diameter squared over 2 squared, otherwise known as diameter squared over 4. And if you do that, you get the following equation. You get rho h pi d squared over 4. Okay. Now again, this part you ain't going to have to do, okay, but in other words, I would somehow this equation would be given to you, okay? So what do we graph to get a straight line out of this? Okay, well, we got mass on the y-axis, and personally, I never change the y-axis. I always keep it mass or linear. I never square that or inverse it or inverse square it or anything like that. Well, how is mass proportional to diameter? Well, mass equals something times diameter squared. So what we're going to graph is we're going to graph mass versus diameter squared. So let's start with that. Now if we do that, we have to make another column here, and it's not a whole lot of room. This will be inches squared, okay? And all you do is square each of these numbers, so you get 36 and 64 and 144 and 196 and 400. Okay, so that's the diameter squared. Now, we're going to make a new graph, and we're going to graph mass versus diameter squared. So you might want to pause the video for a second. I've already kind of started that graph out. We got mass on the y-axis, and we're going to put diameter squared down here. So you can either copy this graph down, or you can use grid paper, or if you just want to watch and get a flavor for it, that's fine too. But I'll pause the video for a sec. I'll pause if you want to go ahead and copy that. All right, we're back. All right, so I've got the mass. I didn't change that from the previous graph at all. Here, we're going to put diameter squared. Now, one mistake that people often make is they'll put, oh, okay, that's inches. No, it's not. That's inches squared. Okay, that's important. That's going to come into play later. Okay. Now, diameter squared went from 36 to 400, so I've made some 4 equal tick marks. Each one's going to be 100. Now, a couple things to note on the graph. On each axis, I have what we call a linear scale. Each tick mark is an equal number. They're each 100. I've labeled the axis with what it is and what units it's measured in. Same thing here, linear axis. Every tick mark is equally spaced. I've written down what I'm graphing, it's d squared, and the correct units, inches squared, okay? Now we're going to plot our points, okay? So looking up there, looking at the original data, if I do the first d squared is about 36, about there, and you go up to 6, you go up to 126, so that's going to be about there. The second one is 64, 224, so that's about 2/3 of the way, and about there. The third one is 144, 500, so 144 is about there, 500 about there. Then we got 196, 686, so just under 200, and just under 700, about there. And the last one is 400, 1400. So there's our 400, and there's our 1400. And within reason, and considering that I'm drawing this on a whiteboard without any real grids, that's pretty linear, okay? If you had grid paper, you'd get a nice, it'd be even a little straighter probably. You would then draw a best fit line with some kind of straight edge. I'll do the best I can here. And it's about there or so. Okay, and then we're going to find the slope of that line. I'm going to pick 2 points that are not data points. Okay, so that's your job. You pick 2 points that are not original data points, and you find the slope like you would in geometry or Algebra 1 class. So I'll pick, looks like about 100, 400. Okay, about 100, 400, give or take. The other one, I'll pick 300 and 1100. Okay, so my 2 points are 100, 400. My second point is 300, 1100. Now, by the way, it does help to actually write the 2 points down you're using, okay? All right, so slope is rise over run, okay? Well, the rise, the slope, the rise, we went from 400 to 1100, that is 700. And the run, we went from 100 to 300, that's 200. So the slope is 3.5, okay? What are the units of the slope? You're going to always be asked, what are the units? Well, since you're now just doing a simple linear slope, it's just the units of the rise over the units of the run. So it's grams per inches squared, okay? Now, that's important. You need to get the number and the units. Now, how does that get us to density? So I'm going to rewrite the equation we had. Mass is equal to rho h pi over 4 times d squared. Well, what do we graph? We graphed mass versus d squared. This is the easiest part of this problem. What does the slope represent? It's whatever's left in the equation. What's left in the equation? This is what's left in the equation. That is the slope, okay? Now there is one more thing I need to give you. I need to tell you the thickness or the height of the pizza. So let's say I told you that. Let's say you get the pizza from wherever and you measure the thickness of it, and we'll just say it's 1/2 inch, okay? So let's say I tell you that the height of the pizza is 1/2 of an inch, all right? What's the density of the pizza? How many grams per inches cubed? So if I have an inch cubed of pizza, which is about like square about that big, cube about that big, what would the mass of it be per cubic inch? Okay, so the density, or the slope, is simply that. Rho h pi over 4. I want rho, so I'll do the math for that. Rho is equal to 4 times the slope over pi h. Okay, and we have all those numbers. We get 4, the slope was 3.5. Now notice the units, by the way. The slope was grams per inches squared, right? In the denominator, we have pi, and we have height, which is 1/2, and that is inches, okay? If you do the numbers really quick, I'll do that really quick. That's 1428 over pi. So you get the rho is 8.9, okay? And what are the units? Well, if you multiply top and bottom of this fraction by inches squared, okay, these cancel out. You have grams per inches cubed. So the density of the pizza is 8.9 grams per cubic inch of pizza, okay? So that's an example of curve straightening. That's not a physics curve straightening, but curve straightening is curve straightening. It doesn't matter if it's physics or math or whatever you're measuring. So again, some keys. Figure out what relationship you got between your original variables. That's step one. Step two, you have to know the relationship or be given it, okay? So what's the relationship between mass and diameter? Well, here it is. So this for this example would be given to you in class. What do you got to graph to straighten this out? Mass and diameter squared. You graph the mass versus diameter squared. Make sure you do the same thing to the units that you're doing to the variable. For squaring d, it's got to be inches squared. You find the slope of that best fit line, and you use points that are not data points. Clearly, those are not data points. You find the slope, you look at the units of the slope, okay, you make sure you write that down, and then the slope is whatever's left in your equation that you didn't put on the graph. So this is what's left in our equation, that's the slope. You set the slope, which you got a number for, equal to that, and you also play with the units, okay? And that gives you the right number and the right units for whatever they're asking you for. So we hope that was helpful. Thank you very much.